Hello and welcome to a lecture on car efficiency. This is for my Excel class and it's based on a car efficiency project that they will be doing. So I won't be giving all the answers in Excel today, but the basics of car efficiency equations. So let's take an overall look first at car efficiency. So here's a graph of car efficiency over the years, and you can see the y-axis, excuse me, is miles per gallon, and the x-axis is years. And I've blocked off all the years after 2005 for now, but I'll show them in a second. And you can see that in the 80s, car efficiency gains started happening, and same with trucks, and the whole fleet was improving efficiency. But it really stagnated after 85, and even until 2005, there weren't that many gains in the overall fleet, which is the red squares. But we can see here that after 2005, increases really started to take off. And this was policy driven mostly. And we can also see that after that line is projections into the future, and this was from 2011, so these were projections after 2011, that efficiency would just keep rising. And again, this is from policy choices. So we've made a policy choice to make cars more efficient, and I just want to sort of go over some of the implications of having a more efficient vehicle through some calculations. So we're going to discuss 4 different types of cars. The internal combustion engine is the car that we're used to. You know, the 6-cylinder engine or the 4-cylinder engine or whatnot. And I'm not going to go into too much detail about hybrid electric cars, or plug-in hybrid cars, but I am going to use a lot of their implications when we do efficiency calculations. But let me just go over a sentence or two here about each car. Hybrid electric cars run just on gasoline, but they have an onboard battery that recharges via regenerative braking that can really increase the fuel efficiency. So all the calculations are going to be the same. They just have a higher fuel efficiency most of the time than internal combustion engine vehicles. Electric cars run fully on electricity. They have an electric motor, an electric battery, and that's it. So that's electric vehicles in a nutshell. So we'll learn how to deal with those. Plug-in hybrids are a little weird. Plug-in hybrids act like electric cars for a little while, and then once their batteries are drained, they act like hybrid electric cars. So, for example, the Prius plug-in, which is what we're going to look at, goes 11 miles on all electricity, and then has a range of over 400 miles on gasoline after that. So they're a little bit different to deal with. And I provided a few links here. All links are to fueleconomy.gov, and they have a lot more explanation about each of these car types. All right, so what we really want to answer is, what does it cost to fuel these different car types? And for all of our cars, we're going to use the same assumptions. We're going to use $4 a gallon for gasoline. We're going to use 5 cents a kilowatt hour for electricity. And why we're doing that is because electric cars can usually be charged at off-peak rate, so at night or whatnot. That's usually lower than the average rate of electricity, and that's why we can use a cheaper rate for electricity. We're going to assume 15,000 miles driving a year and 2 trips a day, and that equates to 2 trips a day of 20.55 miles. That'll be important when we get to the plug-in hybrid. And that 75% of that driving is in the city and 25% in the highway. And all the individual car assumptions that I'm going to give you are from the fueleconomy.gov website. So let's first look at an internal combustion calculation example. So this is the Honda Accord. It retails for 21,955, and the city miles per gallon is 26, and the highway miles per gallon is 34. So the city costs, remember, we're 75% is driving in the city, and we have the miles per year, which is 15,000. And then this is our 26 miles per gallon. We have $4 a gallon here. So the total cost for city is 1,731. We do the same exact thing for highway cost. So 25%, 15,000 miles per year, and the miles per gallon here. And we get $441 per year. So it's a total of a little bit over $2,172 to drive this Honda Accord. So let's look at a hybrid. And why not look at the same exact hybrid, the Honda Accord hybrid. Again, there's the MSRP is 29,000 about. City miles per gallon is 50, and highway miles per gallon is 45. That's another interesting thing to know about hybrids, is that normally their city miles per gallon is higher than their highway miles per gallon. That's a little counterintuitive because most cars, this is the opposite. And this is just because um, the internal combustion engine usually shuts off in a hybrid when you're at low speeds or when you're stopped. So let's look at the calculation. So this calculation is exactly the same. We just insert the miles per gallon um, different. So it's 50 miles per gallon for the city and 45 miles per gallon for the highway, and we get the different costs, and it's about $1,200 a year. So same exact calculation, just different, just higher miles per gallon, which leads to a lower cost. Okay, so let's talk about electric cars. So electric cars, you have to plug in, and these are two pictures of electric cars. And the bottom one is the Nissan Leaf, and the top one is the Tesla Model S. The Tesla Model S is more of a high-end sports car, and the Nissan Leaf is more, your typical consumer car. And you can see it plugs right into the wall. So you have to, instead of going to the gas station, you actually charge it at home or at your office or anywhere where you can find an outlet, really. So that's the idea of electric cars. So if you go and try to look up the efficiency of electric cars, it gives you something here. So we have the MSRP, so that's with the tax break, it's about 21,980. But what's really weird is this MPGE. So what is the MPGE? So we saw before there was just miles per gallon, so that was easy because it's just miles per gallon of gasoline. So let's look at what this MPGE is. So MPGE really stands for miles per gallon equivalent because we're not putting any gasoline into our car, so gallons doesn't make any sense because there's not gallons of gasoline. We're putting electricity into the car. So we're really talking about gallons equivalent. So think about this example. If you use the amount of electricity that is energetically equal to 1 gallon of gasoline, and your car goes 126 miles, your car's efficiency was 126 miles per gallon equivalent. So that's why it means gallon equivalent, because we're using the energy equivalent of 1 gallon of gasoline. We're not using any gasoline, just 1 gallon equivalent of energy. So let's see how to go from something miles per gallon equivalent doesn't really help us when we have the dollars per kilowatt hour cost. So really what we want is a measure of miles per kilowatt hour. So we start with the 126 miles per gallon equivalent, and then a gallon equivalent is the energy in 1 gallon of gasoline is 115,000 BTUs, so this is just a conversion factor. Another conversion factor is we know that there's 3.412 BTUs in 1 watt hour, and one more conversion factor, there's 1,000 watt hours per 1 kilowatt hour. So that means 126 miles per gallon equivalent is 3.74 miles per kilowatt hour. So we're going to want to do this calculation a bunch of times, and we don't want to go through all the steps. So what we do is we combine these three in the middle into one conversion factor. And what that means is that 1 mile per gallon equivalent equals 0.02967 miles per kilowatt hour. So we're going to use that from now on to convert our miles per gallon equivalent to miles per kilowatt hour. So let's look at the calculation for the Nissan Leaf. So now we know our miles per gallon equivalent are miles per kilowatt hour. And when the annual city cost, same thing, except now instead of miles per gallon, we have miles per kilowatt hour. And instead of $4 per gallon, we have how many dollars per kilowatt hour we use. So you can see we did the same thing for the annual highway cost, except it's a different miles per kilowatt hour. And we get a total cost of $213 a year. So it's a lot less driving on electricity than driving on gasoline. Okay, so let's look at the plug-in hybrids now. So what a plug-in, like I said before, the main difference of the plug-in hybrid is that part of the time it acts like an electric car, and then part of the time it acts like a gasoline car. So let's look. So for the Prius plug-in hybrid, the manufacturer's suggested retail price is about $27,400. So if it's on all electric mode, which you can see I say it's 11-mile range, then it has, just like an electric car, it has a miles per gallon equivalent for the city and for the highway. And then after 11 miles, it switches over to gasoline, and then it has just like a regular gasoline miles per gallon for both the city and the highway. So you can see it's a little more complicated than the other cars. So now we have that 2 trips of 20.55 miles per day. Remember I said we were going to use this with our plug-in vehicles? So what that means is that in each trip, we use 11 miles of electric driving, so it's a total of 22 miles of electric driving. And then after that, for the next 9.55 miles, we're going to be doing gasoline driving, because remember, it's 11-mile electric range, okay? And so that totals 19.1 miles of gasoline driving per day. So these are the miles per year, and we just converted that by multiplying by 365. So these are the miles per year that we're going to be driving in each case. So now we have not only we have an electric annual city cost, which we get the same way as our electric vehicle, an electric annual highway cost, which again we get the same way as we did with an electric vehicle, but we also have the gasoline city cost and the gasoline highway cost, which we get exactly like we did with the previous gasoline vehicles. So now we have just these 4 calculations instead of 2. And if we add all those calculations up, the Prius plug-in totals $698 a year. So let's just summarize here. We can see that the internal combustion engine is by far the most expensive, and then the hybrid electric car is the next expensive, and a plug-in hybrid is the next expensive, and an electric car is the next expensive. Now, this isn't always going to be the case for all electric cars and all hybrid cars and all internal combustion cars. It really depends on the specific car that you look at. But in general, this is mostly true. So the only other thing I want to cover with this is a simple payback. So, for example, if I bought a Honda Accord hybrid, the first example I'm going to go over, if I bought a Honda Accord hybrid instead of a Honda Accord, what would be my simple payback? Well, we have the 2 costs there. So it's 21, so you pay more for the hybrid, and then you spend more if you have the regular Honda Accord on gasoline than you would if you had the Honda Accord hybrid. So a simple payback is just the cost difference, so that's the numerator, that's the cost difference, divided by the cost savings per year. So in this case, it would take 7.67 years to pay back for buying the hybrid. So then let's look at another example. This one's a little bit different. If we bought a Prius plug-in instead of a Honda Accord hybrid, what would be your simple payback? Okay, so if we look at the cost for the Prius plug-in is actually less than the cost for the Honda Accord hybrid. And the Prius plug-in runs, it uses less money to run per year than the Honda Accord hybrid. So since the Prius plug-in costs less upfront and costs less to run, there is no payback. The Prius plug-in is basically a win-win situation. Costs less upfront and it costs less to run per year. So if you're building a spreadsheet to calculate this, make sure that if this situation comes up, that you deal with it accordingly. Okay, so your goal for this assignment is to create a spreadsheet that can be used by anyone that gives a simple payback of purchasing one car over another car. So all of the global assumptions that I went over before should be able to be changed by the user. So here's the rubric for your assignment. So your data and calculations should be really easy to follow. That's part of the organization. And you should have a good sort of font style and border style, so it's easy for me to locate data, and it's easy for the user to locate anything they're looking for and read things very easily. All your calculations need to be correct if you're going to get full credit for the calculation correctness. And the big thing is the ease of use. So I want this Excel sheet to be able to be used by anybody, and even if they're not technical audience. And then functionality. To score perfect on the functionality, the Excel sheet should work all the time, with no errors or whatnot, and unless the user inputs an invalid number. And the database should include more than 10 cars and include both electric and plug-in cars. So, there should be a good variety of cars that you have in there. So good luck with this assignment.